Welcome to The Explainer. Today we're going to dive into a topic that is absolutely essential for anyone working in cloud computing, Azure Virtual Networking. Seriously, if you've ever needed to securely manage your resources in the cloud, this explainer is going to give you the perfect mental model to get it right.
So let's just imagine this for a second. Your apps are running happily in the Azure cloud, but your most critical data? That's still sitting in your on-premises office. How in the world do you build a secure bridge to connect these two completely separate worlds? Well, that's the exact problem Azure Virtual Networking is designed to solve. And the solution is something called a virtual network, or a VNet for short. The best way to wrap your head around it is to think of a VNet as your very own private, secure office building that you get to build from the ground up entirely inside the cloud. It's totally secure, it's isolated, and honestly, every single thing we talk about next will fit right into this one simple analogy.
Now, every good building needs a blueprint, right? And here's ours. First, we're going to secure the land for our private cloud office. Then we'll design the floor plan, figure out how to connect it to the outside world, build a secure bridge all the way back to your headquarters, and finally, we'll install the security systems to control all the traffic. All right, let's get building. Okay, first things first. Before we can even think about building up, we have to secure our plot of land. This first step is all about carving out a private, totally isolated space in the massive world of Azure that belongs only to you. So when you create a VNet, what you're really doing is defining a private range of IP addresses. It's kind of like putting up a giant, invisible fence around your property. By default, anything you decide to build inside that fence is completely invisible and, more importantly, inaccessible from the public internet. It's your own private bubble in the cloud. All right, our secure plot of land is established. Now it's time to actually design the inside of our office building. And to do that, we're going to use something called subnets. It's really just a two-step process. We've already done step one, right? We claimed our land. That's our IP address space. Now, for step two, we just divide that bigger space into smaller, more manageable chunks called subnets. Think of a subnet as a specific floor in your building, or maybe a dedicated department. One for your web servers, another for your databases. This segmentation is absolutely key, not just for organization, but for security too. Okay, our building is designed, but an office that's completely isolated isn't all that useful, is it? It's basically a fortress. We need to be able to communicate with the outside world and with other services. So let's talk about how our VNet actually does that. So our building basically needs two kinds of doors. The first one is the main public entrance, the lobby. We call this a public endpoint. It gets a public IP address, and it's how you can be accessible from the internet. But the second door, that's the private endpoint. You should think of this like the building's internal intercom system. It's only for secure, private communication within Azure, connecting your different departments without ever exposing them to the outside world. And let me tell you, that internal intercom is incredibly powerful. It lets you securely connect your VNet to all kinds of different Azure resources. Your virtual machines can talk directly to an Azure SQL database, or your app service can pull files from a storage account. And it's all happening securely inside that private network boundary we created. So we've connected all of our cloud resources. They're all talking to each other. But what about that other half of our digital world we mentioned right at the start? We still need to connect our shiny new cloud office back to our physical on-premises headquarters. Well, Azure gives us three fantastic options here. And each one has a perfect analogy. A point-to-site VPN, that's like a secure keycard for a single employee working from home. A site-to-site VPN is more like a secure encrypted shuttle bus that connects your entire on-site office to the cloud office. But for the biggest, most high-security needs, there's Azure Express Route. That's a dedicated private underground tunnel that goes directly into the cloud. It doesn't even touch the public internet. Okay, our digital building is now fully connected. We've got internal wiring, we've got a public entrance, we even have a secure tunnel back to HQ. But right now, it's kind of chaos. The next logical step is to manage who can go where. We need some rules, we need security guards, and a building directory. So let's start with the security guards. These are called Network Security Groups, or NSGs.
What you do is you attach an NSG to each subnet, so to each floor of your building, and it acts like a guard with a very, very specific list. It checks all the traffic coming in and going out, and it decides whether to allow or deny it based on a set of rules you create, like where it's coming from, where it's going, and even which port it's trying to use. So if NSGs are the security guards, then route tables are the building's directory and all its signs. See, by default, Azure is pretty smart, and it routes traffic in the most efficient way. But with custom route tables, you can override that. You can create your own rules that say, hey, any and all traffic from the web server floor that's headed for the internet must go through this special security appliance first. It gives you incredibly precise control over the exact path your data takes.
We did it. We've designed, built, connected, and secured our digital office building. Now let's just take a step back, zoom out, and really look at why this whole framework is so incredibly powerful.
So what does all this get you? The end result is a network that gives you three critical things. First, isolation from the public internet. Second, segmentation of all your resources into nice logical groups. And third, unbelievably granular control over how everything talks to everything else. This is the framework that lets you build really complex, really secure, and high-performing applications in the cloud. But hold on, the big picture doesn't stop with just one building. I mean, what happens when your company starts to grow and you need a second office? Maybe you've got one in the US and you need another one in Europe. How do you connect them securely? The answer is something amazing called VNet peering. It lets you connect two totally separate VNets so they can function as if they were one single network. All the traffic between them travels exclusively on Microsoft's own private global network, which makes it super fast and super secure. It's just like building a private sky bridge between your two digital offices, even if they're on opposite sides of the planet.
And there you have it. You now have the blueprint. You can build a secure, an isolated, and a globally connected digital headquarters right there in the cloud. The foundation is laid. The security is in place. So the only question left is, what are you going to create inside?